today we are live. It is the AWS AI Infrastructure Innovation Day. I am still, and will always be, A.M. Grabelny, joined by my wonderful co-host, Jasmine
Hello.
Giles. Hey.
Hi.
How's it going? Look at that. We spent too much time.
Look at it.
We're completing each other's sandwiches. Sai, down here, please tell the people about yourself.
Hello, everyone. My name is Sai Venom, and I'm a Principal Solutions Architect at AWS. I focus primarily on containers and Kubernetes. I'm actually really excited to be on this side of the picture today because I do run a show on YouTube called Containers from the Couch. It's an AWS channel, and I'm usually the host, so I'm excited. I get to be the one talking about tech and doing the demos.
Yeah. I love you getting that plug in early. That's nice, Sai. Very, very cool. Should I get my plugs in too? You want to? No. Okay, we'll do that later. Anyway,
later.
Yes, I'm a big fan of Containers from the Couch. Actually, been watching it for a long time, back when Brent was still running it. Anyway, moving on. We're in my realm now. This is also my realm, the containers world, the Kubernetes world. I feel at home in this place. So I'm really excited to talk to you, Sai, of this intersection between Kubernetes and generative AI. It sounds like, so today we're just focused, I want to clarify, we're just focused on deploying a model within a Kubernetes environment for inference. But Kubernetes in general is used for a lot of the ML kind of workflows. Is that true?
Yeah, absolutely. We're seeing a lot of customers using Kubernetes for building, training, and serving AI models. So let's actually take it a step back. I think
please.
With AI and ML, one of the big things that really led the way with the generative AI revolution was the ability to very quickly fine-tune and serve these models. Even 10 years ago, these models were really specialized, really focused. They were hard to build up from the ground. And so a lot of the things that we're seeing customers do with Kubernetes, especially Amazon EKS, Elastic Kubernetes Service, basically managed Kubernetes, is building these foundational models and then taking it a step further, fine-tuning them, and then serving them up so that others can use those inference APIs.
Right, yeah, we're running into this world of I've heard, maybe this is probably not even a term people are using anymore because that's how out of date I am, but like an MLOps type, where we're doing the same types of automations that we see in the DevOps world, right? Like from getting code to production. Same thing with a model, right? Getting it from training to production. You have to have these processes in place, and people often choose Kubernetes because it's like a unified environment, right? Is that what you're seeing?
Yeah, and I think that's one of the great advantages of Kubernetes is this open source ecosystem, especially when working with things like foundational models. They have a lot of very specific requirements, like the type of infrastructure they need to run on. If it was built and compiled on one type of hardware architecture, then it also needs to be served on that type of architecture. Lots of little fine-tuning things that you really need to be able to customize. And so for building these foundational models, and especially for customers that have those operations teams that have familiarity with Kubernetes, it makes a lot of sense to run these type of workloads on Amazon EKS.
Yeah. So tell us, what does this mean for the scalability and availability?
I'm really glad you brought that up because that's a really big advantage of Kubernetes. It's that scalability aspect of, when you need that compute, let's scale up on demand. Let's get all of that, access all of that EC2 that's available out there. And then when you no longer need it, Kubernetes does a great job of scaling it down. In addition, a lot of that innovation that happens at that EC2 layer, that compute layer, is something that Kubernetes doesn't hide from you. Yes, maybe it abstracts it a little bit, makes it easier to leverage. But the idea is that, by abstracting some of those complexities, you still leverage the innovation happening at that EC2 layer without having to really get into the nitty-gritty of it all the time. One quick example of this is EC2 capacity blocks, which work with self-managed node groups and managed node groups on EKS. The managed piece is more recent. Essentially being able to reserve instances when you know you're going to need them.
Yeah. So essentially what that does is, it puts these resources on demand for you, and then whenever you're ready to go and access them, those models are ready to scale.
Exactly. Yeah.
Okay.
Got it.
Nice.
Sai, you already mentioned this too. A big part of Kubernetes popularity and usage is around the ecosystem, the tooling, right? Kubernetes users love the tools, right? So are there specific tools for use when working with deploying models in a Kubernetes environment?
Yes. So one of the stacks that are getting built out right now, I think we're seeing more and more customers using this stack. We're calling it JARC. So we'll walk through that really quickly.
Okay.
The J stands for Jupyter Hub. I think everyone knows what Jupyter Hub is used for at this point, but notebooks to be able to kind of work with these AI models, develop them out. A here stands for Argo CD, which is the CI/CD capabilities, which you kind of referenced this earlier, where the workload here lends itself well to Kubernetes because previously it was application workloads that you needed CI/CD workflows to really develop iteratively.
Yeah, I've used Argo for deploying code, right? Like not necessarily models, but just day-to-day code, right, for application development work.
Right. And now all of that innovation that's happened in that space, we're just saying, here, now apply it to AI/ML. So let's keep going down the JARC stack.
We're to R.
The R is Ray. So Ray is an open source framework used for building, training, inferencing with AI/ML models. It works, it helps you work directly with models that are out there on places like Hugging Face. And the cool part about it is it makes it really easy to make those APIs to work with the models. So you'll see in the demo today, I just pick a model and I say, all right, deploy this. It'll handle the scaling of it out on Kubernetes, automatic scaling, and it gives me an API that I can hit. And by the way, later today, I'm going to ask you in the demo to give me a prompt for our stable diffusion, and we'll generate an image live. So
Wow.
Okay.
Yeah.
All right. Challenge
We're in the hot seat.
accepted.
Yeah.
Oh no, it's already happening. Sorry, ideas formulating.
let's keep it PG, right, guys?
Oh yeah,
Oh, always.
my default setting.
And the K is
K.
Kubernetes.
Oh, okay. All right, great. I love a good acronym for a technology stack. I remember the MERN stack from days ago. LAMP stack, of course. Look, we could go on for days and days. And JARC, it's coming into the lexicon. I can feel it. So I feel you bringing it in. Thank you for that.
Yeah, people like acronyms. So
Yeah. You're going to show us the JARC stack running on EKS, yeah?
Yeah, let's do it.
Let's do it.
Right.
Awesome. So right off the bat, I'm in the AWS console, tried, true, familiar. Let's take it even one step lower. Again, earlier I was talking about abstracting away, complexity. So at the very bottom here, EC2, the basis of everything that we've got running today. Take it one step higher. We're going to get into EKS, where I've got one cluster running. Those nodes that we just saw in EC2, by the way, are being managed by our EKS cluster.
Okay.
So if we go into our EKS cluster and hit compute, we'll see those same nodes. We also have some node groups here that you'll see are scaled down to 0, and that's because, well, I'm not using them right now. There's some Trainium node groups and Inferentia node groups, and that's good. I don't want to pay for something I'm not using, and those are scaled down to 0, so I'm paying 0 on those. And for the ones that I am using, which I deployed very recently here about an hour ago on the Inferentia 2 24x large and the R5x large. The Inferentia 2, by the way, this is accelerated compute at its best, enabling us to deploy and serve the stable diffusion model that we're going to be running today. That's going to be ready to run. And so this is kind of the next layer up. So we've got EC2, now Kubernetes, but we're missing one more piece. It's from that JARC stack, the Ray component. And Ray is essentially going to make it just a little bit easier to work with Kubernetes and that underlying EC2. It automatically scales up the things that I deploy in it. So we can see the application config here. You'll see that I passed in this particular model ID. And if we go to Hugging Face, it's that exact same model ID right there. So
That's just hosting your model then within your cluster
That's right.
through Ray. Let me ask you, Sai, real quick. As you're setting up, deploying to nodes, things like that, I imagine these are all just like manifests, like Kubernetes manifests that you can manage, with whatever tooling you use, like control or kubectl, however you'd like, or Helm or something like that. So it just, is that true, first? And second, it just makes it, very familiar for anybody who's working in Kubernetes day to day to deploy this type of workload out.
Exactly. I think that's a great point. The people that are your data scientists are not always the same people that are your cluster admins. In fact, I would be impressed if your cluster admins are also your data scientists.
Yeah, me too.
And so for the cluster administrators, when they are working with Kubernetes resources, you'll see a lot of this stuff looks really familiar.
Yeah.
By the way, I do want to point out that we're using Carpenter here.
What's Carpenter?
Carpenter is an open source tool that runs on Kubernetes that allows you to manage nodes at scale. Now, what I think is really cool about it, it gives you a very human, readable approach. It's a native way of thinking about the kind of nodes you want to deploy in a Kubernetes cluster. So instead of me having to memorize, I need an INF2 X large or 48 X large, I just tell Carpenter, I need an Inferentia 2 instance. I need it to be an AMD 64, and I'm okay with using on-demand, or if you've got Spot for me, let's use Spot. Yeah.
Which is nice.
Exactly.
Cost efficient.
And it's what's really cool is that that's all I need to determine. I don't need to go in and say these are the exact type of nodes I want. And Carpenter, depending on what Ray is requesting, will spin up the nodes that I need.
That's cool.
And so let's take a look at what it's decided to spin up. I'm using an open source tool here called EKS Node Viewer. That looks messy, so let me just reopen that. Boom. Okay, so it's making it a little bigger. You'll notice that it's got that, it's decided on a 24x large instance for the primary serving of the model that I've got here.
Okay.
So this is I think one of the cooler use cases with Kubernetes when you add this Carpenter layer, just now allowing you to automatically pick the nodes you need without really concerning yourself with that underlying EC2 layer. Carpenter, make the decisions for me. I'm happy with that.
Very cool. I even noticed it's giving you, I assume, estimated cost per month, per hour. That's really handy too, just to have that in a terminal. That's crazy.
It's pretty cool to see. EKS-node-viewer open source tool. It's on GitHub. I think it's a cool visual way of seeing what's going on in a cluster. Cool. Okay, so one thing that I want to switch to here is just kind of showing what's running in the Kubernetes cluster itself. So over here, we can see that in the cluster, we've got Carpenter, as we've talked about. We've got some observability things like Grafana, an Nginx controller, which gives us a load balancer that we can access, and Ray running as well. In addition, very quickly, we can look at the stable diffusion namespace. By the way, this tool is called K9S. It's a great way of just navigating a Kubernetes cluster, see what's running in your cluster. You can see here I've got a head and a worker for stable diffusion running here as well. So that's kind of the underlying layer. I think that's about all that I want to get into the technical details. Yeah. Everything is up and running, as you can see. This is, again, the Ray dashboard where I think data scientists will likely be using this dashboard regularly because it lays things out nicely for what you want to see. Should we get into the fun bits?
We should.
I think so.
And you gave us a challenge not too long ago.
Yes,
so.
Yes. So, by the way, I'm using Gradio for building out a user interface here. Now, I could just go to this endpoint and run, I think, something like /serve, and then I have an endpoint
that I string in for
and I
prompt.
I could do that, but Gradio is really nice about making a nice, easy, human readable user interface. I configured it with that exact same URL from before. You can kind of see it. I'll show the code. Here's the service name that I just passed in, built the Docker image, running it on my local instance. So boom, I've got it up here running. What's our prompt? What do we got?
Jasmine?
I just threw a Hail Mary at chat and said, help us.
I mean, I have one.
It's going to have to do something with an unidentified flying object, if I can guess.
I mean, Jasmine, that's a little bit of an outdated terminology. We have moved on to unidentified aerial phenomena in the community. That's okay. I forgive
I'm
you.
sorry. I wish I would have gotten that right. Did you know that?
I'll get you some literature. I'll get you
didn't know
some
that.
literature. I'll get you some books.
Okay.
Don't worry.
I can't wait.
Don't worry. Let's do an unidentified. We can use the old one. Unidentified flying object pizza. Two of my favorite things.
With pineapples.
Will the model accept that? Is Stable Diffusion able to
I'm fairly certain
pineapple on pizza?
It's okay.
it's going to crash
It's
everything.
a running
if I
joke
do.
on AWS OnAir about pineapple on pizzas.
Please no.
Yeah.
What graphic style do we want? Do we want like comic style, maybe realistic? What are we feeling?
Oh, it's going to be incredibly realistic because
Realistic,
this is
okay.
something I've seen.
Let's make it realistic and colorful. All right.
I'm trying to get
Oh, I like that.
Hit submit.
I'm trying to get an image that I can show on my UAP blog because this is something I encountered myself. Unidentified UAP looked like a pizza. So,
Boom. There we go.
yeah, it kind of looked like that. Actually, that's fair. Yes, yeah. You want to add the pineapple? Let's add the pineapple. Let's do it. Let's do
okay.
pineapple with pineapple. Yeah. We got to do it.
The more detail we put, the better, I think.
Okay.
So let's see if that makes it a little bit closer to looking like a UFO or UFP. I guess.
UAP.
UAP. A UAPP.
I want to apologize to everyone watching. Just kidding.
Oh, that's fun.
Okay. All right.
Well,
I'm
I
not
see
sure.
a pineapple growing out of one of them. Do you see the what are those called? The stem? What's that part of the pineapple called? With the
Stem?
Yeah. Oh,
Stem,
right
is
here.
that it?
Maybe. I don't know.
I didn't know pizzas had stems. Yeah.
yeah, it kind of looks like a sprig of rosemary coming out of it.
So we'll try one more, just so you know. I really want to get that UFO-looking pizza to pop up here.
Yes.
But the cool thing here, by the way, while that's generating, okay, well, it tried.
Oh, the pizza's flying. I mean, that's pretty.
The stars are pineapples.
Oh, they are. I didn't notice that. Chat has told us that we are banned from Italy, actually, for this.
Oh, yeah, the pineapple. So it's not us. I think Jasmine's the one that's actually banned for the
Yeah.
pineapple on the pizza.
Are you a pineapple on pizza person, Jasmine?
Not if it's gonna get me banned from Italy.
Okay. Well, as
Oh, someone in the chat said try pineapple slices.
ooh.
Okay.
All right,
Getting
let's try one more,
specific.
maybe.
You told us we have to get specific with the prompt, so
Okay. Let's try it.
Our pineapple slices on pizza, right? And we lost our unidentified flying object.
Well, let's see what happens with the typo.
Yeah,
Maybe it'll figure it out. By the way, while all this is running in Ray,
Yes, let's talk
let's talk about the
let's
tech
talk
a
about
little bit. So
where the model is.
Yeah, we can actually
deployed.
see it's spinning up additional replicas to handle the load. In fact, there you go.
Okay.
That's looking pretty realistic. Yeah.
Yeah.
So for example, let's
Put that stem there.
they want you to know.
let me just open up a bunch of tabs here, and I'm just gonna have it run multiple times, and I want to show you what happens behind the scenes here a little. It'll start scaling up because it needs more. It needs more. So we're running this prompt 5 times. And so if we go back to Ray, pretty soon here, we should see some logs popping up saying additional replicas spinning up. I might need to hit it like a lot more than that, actually. But, well, let's see if this does it.
It's performing too well for you, Sai. It's too bad.
That's right.
But yes, in theory, it would automatically deploy out new resources
Yeah, exactly.
based on load.
I just realized Gradio is a little bit too smart for us. It's queuing up the requests.
Look at it.
So,
Look at it go.
You must get in line.
exactly.
All right, Sai, we are look, I love this. I love this so much. I love seeing the pizzas. Hoping for more of a UFO shape, but it's okay.
We'll get to it.
UAP shape. There's a lot of UAP shapes out there. Sai, if I want to learn more about working with AI and ML workloads on Kubernetes powered by EKS, what do I do?
I'm glad you asked. So on my screen right now, I've loaded up data on EKS. Hopefully someone can grab a link and throw it in chat as well. Data on EKS is basically your supercharge your data AI/ML journey on EKS. It's your easy way to get started deploying a number of different use cases. So here we've got inference use cases running on either GPU or Inferentia, Llama 2 instances, as well as some other models that you see here. Great way to get started. Highly recommend.
Yeah.
And watch Containers on the Couch.
Yes, watch Containers from the Couch. Thanks for doing the plug for me.
Yeah.
All right. Thanks for joining us, Sai. We will be back with more in just a minute, so stay right where you are.